All right, so we are live. Welcome, everybody. This is our fourth software session. This one is an introduction to the Arduino platform. The Arduino is essentially a small computer, and it's what is the brains of the Elegoo kits. So this one is going to be fairly generic. It's meant to introduce concepts more than actual coding. But there will be some sort of coding in it just to get things to work. So if you are stuck, have questions, let us know on the chat if you are on Zoom and live. If you are watching this on YouTube or later on YouTube recorded, feel free to post any questions in the workshop discussions channel on our Discord server. And you can check with your team if you're not sure how to get onto the Discord server. As I said, this is just an introduction, so there will be two more, one on sensors, one on motors in this series. And if you're still confused, want more information, curious, whatever, you can, again, reach out to that channel on Discord, reach out to your mentors, your fellow teammates, and so on. So this is, as I've been saying, this is just a way to start and kind of get things going, get you thinking about what you can do. So without further ado, I will hand it over to Michael.
All right, thank you, Eric. And hello, everyone. Today, we will be learning about simulating Arduino circuits using Tinkercad circuits. And just as a little disclaimer, this workshop of the series is mostly directed at people who have never used Tinkercad before, so we might be going a bit slower than usual. Also, this workshop won't have any slides this time around, as we'll be learning how to use the Tinkercad circuits interface live. So if you want, you can just minimize this Zoom Meet and listen along. And if you ever get stuck, you can just open this Meet back up. And if you just want to watch, that's fine as well. Now, if you have not already, open up Tinkercad. And if you don't have an account, go ahead and make one now. Don't worry, it's free and it shouldn't take too long. And I won't be going too far ahead at the start. Now, when you first open up Tinkercad, you'll be directed to a home screen that looks something like this. To get to circuits, you have to look over to your left on the sidebar, and just below 3D Designs, which is highlighted blue, there are circuits. Click it to navigate to your circuits dashboard. Once you're there, if you haven't ever created a circuit, it will be empty. And to create a new circuit, click the Create New Circuit button. And once you've done that, you'll be directed to the new design. Now, to actually start doing stuff, we need to drag some components onto the screen. So on the right sidebar, there is a list of components. And scroll down a bit until you see a blue board called the Arduino Uno R3. Click it and drag it somewhere onto the center of the screen. Now the Arduino already actually has some code for us, so we can start practicing running a simulation. Near the top right of your screen under the white bar, there are a few buttons. And one of them says Start Simulation. Once you press it, you should have a green light on your board and an orange light that's turning on and off repeatedly, which is called blinking. Now, just having an Arduino is pretty boring, and your Elegoo cars are a lot more than just an Arduino board. So let's have a little fun by adding some more components to the design. And let's start off simple and just add an LED. So first we have to scroll our components bar back to the top. And once you're there, you can drag the LED onto the interface below, and make sure to put it below the Arduino. Now, you'll notice that this LED is oriented the wrong way around. And to rotate it, you have a couple of options. The first is to select it and press the triangle button, the double triangle button at the top left of your screen. Or if you don't want to do that, you can press R or Shift R on your keyboard to rotate the selected component. Now, once you've rotated the LED so that its gray legs are facing the Arduino, we can wire it up to the Arduino. Now, to wire up the LED so it turns on, we need to add some wires. To do so, we can click on one of the legs of the LED. Now, to do that accurately, you might have to zoom in a little. And to do that, you can just scroll your mouse wheel to zoom in and out. Now, once you've clicked on one of the legs of the LED, you can then click on one of the pins of the Arduino to connect to them. Now, if you missed, then you can just click and drag the ends and move it to wherever else you want. Now, to wire up the LED so that it turns on, connect the cathode leg, which is just a short straight leg, to the ground pin, which is GND on the Arduino. And connect your anode pin to 5 volts. The anode pin is the bent leg one, and it also says when you hover over it. Now, if you got it backwards, then when you press simulate, nothing will happen. But if you did it right, you'll see that your LED is exploding. Now, this is one of the benefits of simulating, since it doesn't cost you anything to break stuff virtually. Now, to fix this, we need to add a resistor to the circuit. And to do that, we need to first delete one of the wires and replace it with a resistor. And you can choose any wire to delete. So I'll just go with this one. And the resistor is right next to the LED. So we can just drag that and plop it on there. Now I'm just going to move this away. Now once you have your resistor, you can wire it back up to 5 volts or ground or whatever you had before, and you can start the simulation again. You'll notice that the LED isn't exploding, it's just on. All right, so that was your little basic introduction on using the interface. Now let's start actually programming the Arduino. And to do that, we need to first stop the simulation if it's running. And next to the Start Simulation button, there's a button that says Code. And when you click it, it will open up the program that's currently loaded on the Arduino. Now here in this workshop, we'll be learning how to use C++ in Tinkercad. So we need to switch over to C++ by clicking the drop-down menu or bar that says Blocks and select Text and press Continue. Now, interestingly, in Arduino code, there is no main function. Instead, there is a setup and a loop function. Basically, setup runs first right after the Arduino starts up for the first time. Or not the first time, whenever it just starts up. And the loop function runs after the setup, and it runs continuously in a loop forever. Right? Now, let's start off with a Hello World program. But in Arduino, Hello World is a little more complicated. First, instead of printing to a console, we need to print it to serial. Now, I won't go into too much depth about serial, but basically, serial is just the way that the Arduino communicates with the computer. Now, before we can print, we need to connect to the computer. And to do that, we write, after pin mode, serial.begin, and in brackets or parentheses, 9600, and a semicolon. Now, make sure that when you write serial, it has a capital S. Now, to actually write something, we make another line in setup and write serial, again, with a capital S, and instead of .begin, we write .write. And in parentheses and in double quotation marks, you can write hello world or anything else that you want to print. And don't forget your semicolon. All right, now let's run the simulation. But you might notice that we're missing the console. So to open the Arduino version of that, we have to open up the serial monitor, which is at the bottom center or wherever it is, usually at the bottom of your screen. And there, after you run your simulation, you'll notice that there's printed hello world or whatever you chose to print. Now, this printing, the idea itself is something to really take note of, because when you write a program, it's hard to tell what it's actually doing on the Arduino. So what you can do is have a print statement at critical points of your programs, or you can print out the values of variables to see where or which one is wrong. And this is called debugging, and you'll be using this skill a lot when you're first starting out. All right, the second thing that I would have you do is write a blink program. But luckily for you, the blink program is already there. And let's dissect it because it will teach us on using the Arduino pins. So in your setup function, there is a statement that says pin mode. Now every pin can either be an input or an output, which means the pin can either receive a signal or send a signal. What this statement is doing exactly is it's setting pin 13 to be output. And remember, we have to do this, calling pin mode, every time before we can use a pin, because before a pin can be used, it needs to have a mode. All right, so now that we know how to set up a pin, if we look at the loop function, we'll see how to actually use that pin. There are two functions, digital write and delay. Digital write is what we use to write a signal to the pin, send a signal. And here, high just means turning it on. Next is a delay statement. Now, delay just pauses the program for a certain amount of time. It forces the program just to do nothing. And here, it's pausing for 1000 milliseconds. And 1000 milliseconds is just 1 second. So after 1 second, there is another digital write statement, except this time it's setting pin 13 to be low, which means off. And finally, there is another delay for 1 second. So now, if you want, you can add more digital write and delay statements to create a pattern with that small blinking LED. Or if you know Morse code, you can try blinking a letter or two. So I'll give everybody a minute or two to just create your own pattern with this LED. But you may notice that you aren't able to type anything, and that might be because you're currently running the simulation. Tinkercad doesn't let you edit your code when a simulation is running. So to actually start editing your code, you have to press the stop simulation button. All right. Now is your minute or so to modify the program. And if anybody has any questions so far, now will be the time to ask them. All right, I think you should have had enough time by now. If anybody needs more time, then feel free to say so in the chat. And we have a question in the chat. Why are we using pin 13? Well, on the Arduino, on most Arduinos, and on this Arduino Uno, the pin 13 already has a built-in LED, and that built-in LED is connected to pin 13. And we use it so that we don't have to wire up something external to test a couple of things on the Arduino and to make sure it works. So that's why we're using pin 13, because there is a built-in LED on pin 13. All right, and since nobody has said anything about needing more time, I'm going to give you a quality of life tip. Now that you've hopefully modified your program, what are you going to do if you want to change it so that you're writing to pin 12 instead of pin 13? Now you have to change the number on every single digital write statement. In fact, what if you forget which pin you want it to change to? Then you would have to test out which pin is actually the right pin that you want to change to. and this would be unnecessarily wasting time. So to fix this and prevent that from happening, what you would do is you would create a pin variable that would hold that pin number, and it gives that pin a name so you don't have to remember what it is. To create one, just declare a int type variable globally, and globally means outside of any function and at the top of your program, and give it an appropriate name. So I will create int LED pin and pin 13. Now, once you replace all these 13s with LED pin, now it's going to be super quick and easy to change pin numbers. All you have to do is just change one number at the top of your program, and you'll be using that new pin. Now, if you just give me a quick moment. All right, sorry about that. Where were we? Ah, yes. So, after that quality of life tip, we're going to do our third and final thing for this workshop, and that is to import a library. Now, when you use external components in Arduino, such as using a servo or motors, usually it's going to take actually a lot more code than you expect to start using that component. Now, instead of reinventing the wheel every time you want to move a servo, what you would normally do is just import a library that already has that code for you. And in this case, we're going to import the servo library. Now, to do so, right at the very top of your program, even above your pin variable, and write # or hashtag or whatever you want to call it, import, and in angle brackets, servo.h. Now make sure that you're using those angled brackets and that servo has a capital S. All right. Now, once you've done that, you can create a special servo object. And I won't be going into detail about what this code is doing, but if you just write the following 3 to 4 lines, you will have successfully used a library. And sorry, did somebody mention a question?
Yeah, Jeff was asking if there's a way to find replace to change the whole program, so a text editor feature.
I am not sure if you can do that. Nope, that is just opening my history. So it looks like you don't have a find replace feature, unless I'm missing it.
I don't think so.
Yeah.
You do have it in the if you're using the Arduino IDE natively, I think there's a find and replace.
Yes. And we just got another question. What does serial.begin 9600 mean? So let's just dissect this single statement even further. So serial means that you're talking about the serial connection, and .begin will initiate a connection, which is a protocol in serial communication. And finally, you might be wondering about this 9600 number. That's just a random magical number. Well, it isn't. This number is supposed to specify the baud rate. Now, using serial, you don't have to know about the baud rate. All that you have to know is that the number in serial begin and on your serial monitor just have to be the same so they can properly communicate. Now, in Tinkercad, I don't think you can actually change that number. So you're stuck with having 9600 because it's the default.
Yeah, it's how many bits per second there are in your protocol. So it's a
Yeah.
nice round number in octal in base 8 stuff.
Yeah. And we were importing a servo library. So let's get back to that unless anybody else has any additional questions. And it looks like they don't. So as I mentioned about a minute ago, I talked about creating a servo object. So to do that, you have to start with servo, which is just capital S, servo, and then a name for that object. And I'm going to go for a lowercase servo. So I'm creating a servo object called servo. Don't worry about this too much. So now in your setup, what you're going to do is you're going to add 2 lines. So the first line that you're going to add at the start or the end, doesn't really matter, is servo, or whatever name you chose for your servo object, and dot attach. Now we need a pin to attach to. So if you notice on the top of your Arduino board, there are a bunch of digital pins, and some of them have a tilde or squiggly line. These are what are called PWM pins, and generally motors and servos need to be attached to them so that you can properly control them. So once you've chosen one of these pins that have a squiggly line, you can put that pin number in attach, and I'm just going to choose 10. Alternatively, you could have created another global variable called servo pin and give it a value of 10. But since we're only using it once here, it's not that critical. Sorry, was that a question or was it just some random noise? I think it might have been back.
Yeah,
I think it might have been background. Okay. Anyway, so now that you have written servo.attach or whatever your name was for your servo object, you're going to write the same thing, so the same name, but instead of dot attach, you're going to write dot write. And in the parentheses, you can write 90. 90 is just a nice number for now. And what we're doing here is we're just writing a position to the servo motor. So we're writing 90 degrees, I believe. I don't remember immediately off the top of my head.
Yep.
But, okay. But basically, right now, if you've done everything that I did, you have a program that will control a servo. But to actually test it out, we need to add a servo to design. So let's do that. Exiting the coding menu by pressing the code button, we can scroll down the components bar until we see the micro servo, which looks like a really decorated blue bar. And then you can drag that onto your screen. There we go. Shoot, move away. All right. So once you've got your micro servo onto your design, you'll notice it has 3 pins. And if you hover over those pins, you'll see some names, namely ground, power, and signal. So what you're going to do is you want to connect your ground pin to the ground on the Arduino, which is G and D. And if you want to route it by basically making corners, you can click on thin air or nothing, and it will create a corner for that wire. There we go. That's only if you want neatness. If you don't want neatness, what you can do is you can just click the power pin, and power needs to go for 5 volts, and just directly put it on 5 volts if you can. You might have to delete that wire from the LED if you're not getting there. And this does look messy, but we're not here to make it look good, we're here to make it work. And finally, you have to connect the signal pin to the pin number that you chose from before. And I chose pin 10, so I'm going to connect to pin 10. All right. And if you did everything correctly, when you press start simulation, you should have a servo that moves like that. So I'm just going to take a little pause here for anybody to get any questions. And if it didn't work for you, you can ask that in the chat. All right, it looks like nobody has any questions and that it worked for everyone. So now I'm just going to move on to my final words. So basically, the reason why I got you to use this library is because depending on what you're doing, especially with this Elegoo car, you're going to be importing a bunch of libraries. And libraries are going to help you save time writing code that's already been written. And before I let you go and play around with some Tinkercad circuits, I'm going to tell you something relatively important. The Arduino Uno microprocessor is not fast. In fact, it is slow compared to most computers. And if you have too many operations in your program, your robot could drive over a line, even though it's constantly checking for lines because it's so busy doing all those calculations. Now, realistically, it's not that likely to happen, but it could happen. And to prevent stuff like this from happening, you have to make sure that you're not doing too many intense calculations, like doing multiplication or addition using floats or doubles anywhere in your program. So basically, if you ever see a float or a double pop up in your program because that was an input from a sensor or something like that, just immediately convert it to an int unless it's for printing to serial. All right, now that's out of the way. That's the end of this workshop. You guys have free reign to ask any questions or play around with any of these other parts that you see on your sidebar.
Yeah, don't be shy if there's anything in the code you didn't understand, or any of the wiring. There's quite a bit, like that first LED that Michael put on. That was a dumb LED because it was just connected to ground and 5 volts. So the only useful bit, or the only useful thing that LED could do is tell you the power is on, because when the power to the Arduino is not there, it'll be off. But when the power to the Arduino is there, it's on. There's no software control of that LED. It's a pure hardware LED. Whereas the one that's connected to, that's on the board that's connected to pin 13, that's a smart one. That's one you can control and you can play with. So we could have also taken that LED that's on the bottom of the board, flipped it to the top of the board, put it on pin 12, for example. Now you still have to have that ground coming to a ground, but then you could control that external LED using code. Yeah, exactly. I did not know how to rotate, so I'm glad you taught me that. And the reason we put a resistor in there is, if that wasn't obvious, is that you want to limit the amount of current. If there's no resistor, LEDs don't really have much resistance, so you essentially get infinite current. There you go. So now and that's the other reason why having a variable to set your pin. If something happens and you break a pin in that little hole for number 12, well, you don't have to rewrite your whole program because the hardware broke. You can just cut that pin off, put it into 11, change your LED pin equal to 11, and off you go. And in FRC, that's probably even more important if something gets damaged on the Robo Rio, that you can just very easily switch to a new pin. Hopefully, we won't be running our Elegoos quite as hard as FRC robots. How to rotate things? Yeah, good question.
So to rotate things, you have two options. So your first option is to select your component, and in the top left, you have a double triangle button. That's the rotate button. Or if you don't want to do that, on your keyboard, you can either press R or Shift R to rotate things.
As a side note, I didn't even see your question, Jeff, about what do resistors do. So, but they do limit the current. They limit how much electricity can go through something. For a light bulb, the filament of a light bulb is a resistor. It's a resistor that burns off so much energy, it's light. But LEDs are so energy efficient, and it's a very different process to creating light, that there's almost no resistance. So if you don't put a resistor in, you essentially get infinite power. If you've ever done the current equals voltage times, oh boy, your Ohm's law, when the relationship between voltage, current, and resistance. If you have no resistance, you've got infinite current. V equals IR. Thank you, Jeff. So voltage equals current times resistance. So if the voltage is fixed, the voltage, I'm not sure if those pins operate at 5 volts or 3.3 volts. I don't remember.
I believe they are 5 volts.
5 volts, okay.
And you have your little singular 3.3 down at the bottom.
And that'll be important if you have, because you will get extra parts that hang off of the Arduino. There aren't just what we call passive parts that aren't just resistors and so on. You might get you will get a wireless board, and I'm not sure what voltage it connects to, but some of them will only work at 3.3 volts. So you can't just plug it into a 5 volt output if it can't take that. You have to be a little careful to respect its specs. So if it says 5 volt tolerant and 3.3 compatible, that means you can use either. If it says 3.3 only, don't plug it into the 5 volt. You will get smoke. And as the saying goes, once you let the magic smoke out of the chip, it does not work anymore.
I have also just learned something funny. Apparently, you can short circuit the 5 volts to ground, and it will work perfectly fine.
That'll be a simulator thing. I don't think it'll work
Yes.
perfectly fine in real life.
Just know that if you do this, short circuiting something to ground, bad things happen quickly, fast.
Because again, you have infinite current moving from your 5 volt rail or 5 volt supply down to ground. So you'll probably melt something somewhere. Any other questions, or if you're wondering how to do something else, then go ahead and ask. Worst case, we'll tell you. We'll cover that later in another workshop. And hopefully you also got that concept of the loop. So in the loop function, so the setup, you turn the power on, it runs the setup function from the top to the bottom, and then it never runs the setup function again until you either take the power off and put it back on, or most of these have a reset button. So I think that's the one in the top left in the picture there. That would also cause it to rerun the setup. Once the setup is done, it runs loop, which has, the 10 lines of code or so, 15, I guess. And then it runs loop again, and then it runs loop again over and over and over and over again. I know one common mistake when you start this LED blinking thing is you do digital write and you set your pin high, then you delay 1 second, and then you set your pin to low, and that's all you do. There's just those 3 lines of code. Yeah, exactly that. And what you get in that case is your light always stays on or always stays off. Yeah, you can probably start that. There you go, the light's always on. And that's because if you look at it, what you're actually doing is turning the LED on, waiting a second, and then very quickly turning it off, turning it back on again, because the loop does not, there's no pause between the last line of the loop and the first line of the loop next time around kind of thing. So you're always doing high, wait a second, low high, wait a second, low high. And so that low high, if you had an instrument, an oscilloscope, you could see that LED actually turn off for a very small amount of time, the time it takes to process the digital write, maybe nanoseconds. But to the human eye, you're not going to see that. So it looks like it's on all the time. So make sure you put your delay after each line. You don't forget that you need that pause after both transitions. Any other questions, curiosities, or you good for tonight? Like Michael said, like go play with this. This is awesome. It was even smart enough to show you that LED exploding. So if you do stupid things, this is the time to do it. If you want to fry something, now's the time. Yeah, he's dragging DC motors on. What you'll learn in the DC workshop, as a little spoiler, is the Arduino is not strong enough to drive a DC motor on its own. So we have to use something else to get more power to it. And a servo is usually okay, so a smaller one. An LED is usually okay. Running sensors, they're usually pretty low power for most of them. But yeah, there's a lot of cool stuff you can use out there. Those multicolored LEDs. I believe that's a little buzzer there. There's a switch, yeah. And that ultrasonic sensor is what you will be getting. It's actually, I think it's the other, yeah, I think it's that one. That's the one you'll be getting in your kit. I think you're actually getting 2 of those in the kit, ones with 4 pins. So, and those are going to be covered in the next workshop or the one after, I forget. And you might, those light rings, cool. That's what we use for FRC for the retroreflective green stuff you see on the field. So. You can have a lot of fun with this if this interests you. A potato battery and a lemon battery, different voltages, different current capacities. Yeah, those breadboards. If you need more space to do stuff, you can use breadboards to split out your circuit. So they're kind of ways to expand your wiring, so you don't have to keep dragging to that same pin all the time. The breadboards will probably come in during at least the motor session, because you'll need an external chip. And some popular chips. And single transistors, you can get them in pieces of one. There are billions of them in the computer, but you can have them one at a time here.
Yes, we just got something in the chat. Do note that the breadboards are connected in a special way, but thankfully, Arduino shows you, or Tinkercad, sorry, shows you which ones are connected. Because if you hover over a pin, it shows you which other slots, pins, are also connected to that. And you can notice that there are rails at the top, which have long sections for power and ground and voltage. And all of these are connected vertically or horizontally, or however you want to do it. And we'll be learning about oscilloscopes. That is highly unlikely.
If there are so oscilloscopes are fairly expensive, but you can get very cheaply digital analyzers, which are just oscilloscopes that read high or low. And I've bought those for, I think you can get them for like $30 or $50. Some pretty decent ones that are, I just got one recently. Or if your school has them and you're able to borrow or use them, which obviously is harder now. Definitely at EDSS, we use oscilloscopes occasionally for debugging circuits, not too often. But if you're interested in learning about that, I can certainly talk about it. I've used them at work quite a bit, so.
In the serial monitor, you see something that looks like a high-low graph. That is a good question on what that does. Your answer is, I have no idea. That is, I'm pretty sure there is a library somewhere in the sea of libraries for Arduino that sends signals over the serial connection. Or well, not serials, but like signals data. And this could be what you use to see that data, but I'm not sure.
Yeah, I haven't used that either. Yeah, definitely the serial monitor will be your friend, because you will assume that you did something, and then that won't be the case. You can actually read back pins. There's when you can set pins high and low, but you can also, so you've got the LED pin high and low, you can actually read them back to know what you set them to. So if you're doing some funky programming so that you're not using the high or low keyword, but you're using some variable and you're not actually sure the status of that pin is, you can actually read it out, put it to the serial monitor, and that would be like a digital read LED pin. So you'd have like, you could just serial write the digital read LED pin, and that would give you the current state of it. So things like that. You don't have to learn it all at this point, but what's important to keep in mind is that you do have the ability to communicate back to yourself through the serial monitor what's actually going on, because that's the challenge of programming in embedded systems, what these are called, where you don't have a screen, you don't have a mouse, you don't have speakers usually. So it's very hard to get anything out of it except through the serial port. Making it beep and blink is another way to debug. Blink every time you get here. That is actually a useful way to debug with an oscilloscope.
A little comment about that blinking. Looking at the pin usage on the Elegoo, unless you use a secondary Arduino, I don't think you have any more room for using an extra LED.
I believe we have a breakout of some kind included in the kit that'll give you additional outputs or inputs. I remember we talked about that. I can check the Get of parts. I'm pretty sure there is something. I seem to remember people were excited. We could have more pins, because you're right, the Elegoo robot consumes quite a few pins. There's also a whole board that goes on top of the Arduino for the motor controllers and all the extra circuitry you need for that. Kit of parts. Cables. Yeah, it's a 1 IO expansion board. So if I'll put it in the chat just so people can see it. So we have, all of you will be getting one of these guys, which is an IO expansion board. Okay, so it uses I2C, so it won't be as straightforward to use as the digital writes and digital reads. You'll probably have to use a library, connect to this board using the library, and then it'll have its own way of accessing those pins, because you're using a special, I2C is called integrated chip communication. So it's just it's a special protocol to talk on just a couple of wires, to a clock, a data, a ground, and a power wire. So 4 wires are all you need to have all this extra IO. Learning how to talk to this thing manually is quite a task. In fact, it's very similar to one of my first tasks at work when I graduated from university. But that's what's nice about Arduino, is those libraries can hide all that complexity and just tell you, you know, I would like to open a connection to this board, I would like to talk to this board, and everything is done for you in the background. Yep, there you go. There's the I2C pins on the Arduino, or I2C if you prefer to call it that way.
Interestingly, it's not shown on Tinkercad.
So it must not be able to simulate it.
Oh, they're just not written down. Never mind.
Right,
They're there.
they're there. Yeah, clock and data.
I was a little worried for a second.
Yeah, I love I2C. It's really useful. We have sensors that run through that too, so you can just connect a sensor through that protocol. All right, well, if there are no more questions, we won't keep you any longer. Anything else you want to add, Michael?
Nope, I have nothing else to add.
Cool. Well, I hope you guys learned something. Personally, I love this stuff. It's why I'm an embedded software developer or firmware developer by trade. I've been doing that for most of my 20 years, and I find that really cool. So I hope you guys will get at least somewhat excited by being able to put these things together and talk to them. And it can be overwhelming, but it can also be pretty rewarding, pretty cool to be able to accomplish those things. So don't give up if you get caught and stuck, because you will get stuck. There's no doubts. I get stuck all the time. It's just a matter of working through it and reaching out to us, your friends, and so on if you get stuck. So yeah, stay the course. I should be good. And yeah, enjoy the night.